Okay, so this textbook's asking you to do some things just blindly, and they're saying, hey, if it's a fraction, if it's a rational expression, they want us to do the quotient rule. And you certainly can do the quotient rule. It's not, and sometimes we have to, but I wanted to, and I'll do this with the quotient rule, but I'll also show you another way to do this, which, we're trying to work smart, right? So the quotient rule says take the bottom times the derivative of the top, low d high. See, the low function times the derivative of the high function, upper function, minus the high function, the numerator divided by the derivative of the denominator, high d low, over the low squared. So in this case, the low function is x squared, so it's going to be x squared times the derivative of the numerator, which is 2x plus 5, just applying the power rule, minus the numerator, x squared plus 5x minus 1, times the derivative of the denominator, which is 2x, all over the denominator squared, which is x squared squared, which is x to the fourth, right? So now let me try to move this a little bit and give myself a little more room. So then I'm going to distribute. I want to clean this up a little bit, so I'm going to get 2x cubed plus 5x squared, and then I'm going to distribute the negative and the 2x, so minus 2x cubed minus 10x squared plus 2x all over x to the fourth. And then, we look at those cancel out. I see 5x squared minus 10x squared is negative 5x squared. So that's gone. And then plus 2x, that's over x to the fourth. Then I see I can factor out a common factor of x. So x times negative 5x plus 2 over x to the fourth, and of course then I get negative 5x plus 2 over x to the third. So that's what we get doing the quotient rule. So now consider doing this way. Now, because I've got a monomial in the denominator, I can break this out to x squared over x squared. I'm going to write it out as 3 separate fractions. I do this because I detest the quotient rule. I can do it and I'm good at it, but I think it's a lot of work. I try to take shortcuts if I can. I see x squared divided by x squared is 1, plus 5x over x squared is 5x. And then I'm just stuck with a 1, or I can't do anything with that 1 over x squared. So what does this do for me? Well, I can rewrite this as 1 plus 5 times x to the negative 1 minus 1 times x to the negative 2, which looks promising. That looks like now I can just use power rule stuff. So the derivative of 1 is 0. The derivative of 5 times x to the negative 1 is negative 5x to the negative 2. And then the derivative of negative x to the negative 2 becomes positive 2x to the negative 3. So far, so good, but I don't see that answer I got before, so I'm going to do some rewriting. Negative 5 over x squared plus 2 over x to the third. I want to get a common denominator. I see the common denominator is x to the third, so I'm going to multiply this first fraction by x over x, because that'll make x to the third in the denominator. I'm getting negative 5x plus 2 over x to the 3, and there we go. So I don't know if that seemed easier to you, but it does to me, and I can get the same answer, so there's nothing wrong with that. Now, either do it either way. I don't care which way you do it. As long as you can get it. Now, the one caution with this and what people fall apart with is they'll try to do things like this. They'll say, what if I have that reversed? What if I have x over x plus 3? They'll do some things like this, like say x over x plus x over 3. You can't break up that. Because I could with the other one because it was just a monomial in the bottom, and I can write that out as separate fractions. With this case, I can't do that. I can't break up that sum, right? It's only if it was a product, and in that case, it's difficult. So, make sure you do, you follow order of operations what the problem is. Okay, hopefully this helps.